Welcome back to my channel, and today we'll continue on our deployment of a production grade microservice in a secure Kubernetes cluster. So like we did last time, we talked about the requirement and we look at our CI/CD pipeline. And today again, we're going to go in directly to the next requirement, and then we'll jump into our pipeline and look at how we actually implemented it. So let's quickly look at the requirement again, and from there we'll go to our pipeline. So last week we'll look at these requirements, the technical requirements, which is code security scanning, and we checked how we implemented SaaS using Sonar Cloud and SyncGrip. So now we're able to see how we actually implemented these, and I was able to show you how you can also implement it, how you can create your Sonar Cloud accounts, and how you can also use Kind Cluster to actually provision these resources. Now today we are going to go to the B part, which is container image security. And the requirement is that build Docker image with security best practice. Yes, very important, because most applications you see, what you find out is that they just build Docker image anyhow. They don't optimize their Docker files. They don't optimize the Docker image they build. And that is not best practice. They don't build Docker image with security in mind. No. But we are going to look at how we can build our Docker images with security in mind. And what are the requirements? There's a use a minimal base image, apply distroless or scratch, run containers as not root users, implement multi-stage builds, scan image with tribute for vulnerability, scan image using cosine, and push image really if scan passes define what? Threshold. So I'm going to look at how we can actually implement all of these and more in our CI pipeline, so that you also can also build, secure and optimize what image. Now let's go directly to our pipeline and see what we did there. Okay, fine. As of last week, we were able to look at this very SaaS scan, which was the first requirement, and we were able to dissect it. If you have not watched that video, go back and watch the video. You would know why everything that is written here, why it is written. And this will help you better understand and to write your pipeline in a very secure manner. So now we're going to the other requirements, which is what? Build and scan the government API. Now, like I told you, this application contains of two microservices, the government API and the low validator portal. The low validator portal speaks to the government API, and through the low validator portal, you can register, you can apply for a loan, and you validate if your loan was actually approved. And the loan validator portal will get check from the government API to see if the loan was what? Approved. And under the project folders, you will see we have general info. Under general info, you have the project. Under the project, you have the project node. There you have the government API. So we're going to be dissecting the folders as time goes on, but I just want to give you an overview of it. So let's start. Now, first of all, we write the name of what we are doing. We are building and scanning government API. So there's the job we want to run now. The job is we are building and scanning government API. That is the name of the job. And this job, for it to run, it needs these jobs. That is what we did here. It needs SaaS scan. So it needs this job. So it needs this job. If this job does not complete successfully, this cannot run. And it's very important because it helps to prevent you carrying, using code that is not well scanned, that has a lot of vulnerability, that has a lot of secret coded in it, and you build it into image. So with these steps in place, it means that this must pass the required threshold, must pass, the required minimal acceptable, scan before this job of build government API can run. So that was the reason of these needs. Saska. Then of course you have the runner runs on Ubuntu latest provided by GitHub Actions. Then of course permission, we discussed this the last time. You can go back again and check the last time video. You understand what this permission means. Then of course we have the output. The image tags is going to be output. The image target is going to be why is this necessary? So that we can, other jobs can be able to use these image tags or image targets. So that is why we output them here. Then quickly we're going to look at the steps, and steps is found under jobs. It determines the various things that needs to be done. So the first steps here is checkout, and I told you actions are a way in which many of the code base has been abstracted. So just giving this action of checkout to be able to take your code from your repository and put it to the runner and start running the various jobs you want to run. So that is what this first step does. Action checkout our code. Then the next thing is I logs into the Dockerfile. So for you to be able to push your code, even though the Dockerfile is not private, it needs to log into what? My Dockerfile account. So, and you find that it's going to log in. We still use an action here. You're supposed to write a lot of code or script, but this action will just help you to abstract that. So all you just need now is the Docker Hub username and Docker Hub token. And how do you? These are stored in GitHub secret. That is why we use secret.Docker Hub username, secret.Docker Hub token. Now, how do you store them in the secret? Let me quickly show you. And how do you create a token? Let me quickly show you so that you also can implement this project. So quickly we have, this is my repo. This is my Docker Hub. For you to create a token is very, very easy. You just go here. This is my username that I stored there. Now to create a token, you just quickly click on this and you go to account settings. It's very easy. Account settings, it loads. Then you see personal access token. Look at the tokens that are created so far. So you just click on generate token and you fill in the details. And after filling in details, you just click generate, and that is all. You have generated token. You copy it and you go and store it on your GitHub repository. So how to store your token? You go to settings, then you go to secret and variables, you go to actions, and you click new repository token. You click on it, the repository token, you add the token name, and the value you have copied, you put it here. So the token name for this now will be Docker Hub token, and you put the value that you have copied. It's as simple as what? ABC. So if you see now, you find that I've already stored it on my Docker Hub token. So it's as easy as that. Now let's continue on our pipeline. Now we see, so after then you have the pipeline will log in. You are able to log in into the Docker Hub. What next is you set the image tag, very, very important, and is a best practice. Production standard, we don't use latest, because with latest you will not be able to do so many things. So you use image tag, and what do we do here? First of all, short SHA. We use a SHA, and we got it from the GitHub SHA, and we reduce the number to 7 digits. Now from there, to make it unique, to make the image tag unique, we combine the SHA with the GitHub runner number. So with the GitHub runner number, we compile the SHA. Then also we output it so that other jobs and other runner can also use it. And also we also output the image. We also output the image as GitHub environment, so that we can just environment.image tags, and other runners or at any other place we can also use it. So this is what was just done here to set the image and to make sure the image is being used. And it's very important because with this image tag, the way we set it now, you can easily roll back. Yeah, and you can also use it to trace for audit, to check, your image. You can easily trace your image, you can easily roll back, you can also do many things. So that's why image tag is very, very necessary compared to latest. And you can also detect image with vulnerability as quickly as possible when you have image tag and be able to find the root cause. Now let's go to the meat of the whole thing. Let's now see how we're going to build our government API image. Now we're going to look at the working directory. We have enabled it. The working directory, like I showed you, is a general info, project name, government API, backend, and we have the word Dockerfile. So before we look at the Dockerfile, let us first of all look at the command. So we run a command here. When you use action this time around, it's a command docker build arg, build date. We have this here to S for traceability. Then we look at the ref number. This is also very important to help to trace the image, to help for audits, to help to what? Rollback and all. Also we have the version. This also helps for rollback, for auditing and all. Then of course, we'll now tag the image. Look at our image tag, and how do we tag it? You have the Docker registry. We have my repository. Then we now have the word image tag. So it's as easy as as that. And we already have those values up there. The Docker registry value, we already have it. Look at it. Docker.io. Then my account name is like the namespace. Then of course the repository name, which is what? Government API. Let me show you the repository so that you see what I'm talking about. So you see, this is my repository. So you see it, Michael, this is my namespace, a government API. So you have in default the registry, combination of that namespace and docker.io. So you now have docker.io here, my namespace, then government API. This is it. So this is the repository. Then of course we have the image tag attached to it. So let's quickly go back and see. So of course we have already given a working directory. So inside the working directory we have a Dockerfile. So there we will see find Dockerfile at this working directory. That is what this dot means. A Dockerfile, this working directory, that is what it will follow to build the image. So let's quickly look at the Dockerfile, see how we be able to optimize it and add security measures. So these are Dockerfile, very simple. Well, first of all, is a multi-stage build Dockerfile. When we mean multi-stage, you mean that it's built in different layers, and this helps to reduce your image size and optimize build, and also for security. So it's built in different stages, and at each stage you get what is required. So it has two stages here. So the first one, we use a base image, which we use as builder. And if you notice, we use alpine image, and the alpine image contains Golang, so that you won't need to install Golang, install a lot of things. And it's very light. Alpine image is very light. So we are following the requirement, telling us to use alpine image. So it is very, very important. This is for security reasons, to make your build fast, and also to reduce surface attack. Then we have a working directory app. Then we copy our code into this working directory. Then of course we run our application and build the government API. Now this is very important. All those run and schedule or enable. This way helps to only make the output to be static binary. Static binary to not contains a lot of OS dependencies that will make the image to be large, that will make the image to even be vulnerabilities, leading to security and all. So this command will help to just output only the word binary that has been built that is needed to run the what? Your application. So that is the first stage. Now we'll now enter the second stage. And in this second stage now, you still find out you use a distroless image. What we mean a distroless image? We mean image that is so, simple, that does not contain any, package, that does not contain any shell, that does not contain any bash. So what does this mean? It means it's what? Security conscious and no root image. So what it means is that it makes you to not be vulnerable to attackers, because when the attackers even eventually break in, there will be nowhere to actually run their commands to attack your application. So we use such image here. Distroless is good for security, and it is very, very, very light. So we have a non-root image, and then run your application is what we just need. So we'll just copy it, and when we are copying it, we copy it as what? A non-root user. This is what we have here. The user, that it's a non-user. What this helps us is that if there's any escalation, and the container that is going to be generated from this image will not have access to, root privileges, because it's already running as what? As non-root user, which is the best practice. So we get the outputs, we get the output binaries from this builder. Remember, when we started, this whole process will be as a builder. Then from that builder now, after making the image to the non-root user, then what will now happen is what? We copy this government static binary government API, we copy it into this part, this dot, because that's the working directly. I will copy them on the government word API. And of course, you are just telling this application will run on 8081. And of course, we still said, it's using user. The container is going to be using user, non-root user, and of course, we have the command to run the word application, which is app government word API. Very simple. Now with this Dockerfile, what we expect is a very light image, number one. And what this does is that it makes your pipeline run as fast as possible. Very light image, and these are due to the fact that we use a lot of distroless images, and we did multi-stage build for our application. So security, it's utmost here, and also optimization comes from using a multi-stage build image and also using a distroless images, alpine images, and of course the image size will be very, very, very low, very, very small. So this is what we did here, and of course you see from the pipeline it runs successfully. From the pipeline, you find that the images, the pipeline runs successfully. Let's quickly check it. So we find out that the pipeline run, build and scan image. If you run successfully, you can look at the minute it takes, 1 minute 6 seconds. Or you are running it again. Why? Because you have optimized your image and all. So that will be for it for tonight. So tomorrow or next time, we're going to talk about how we can run trivial scan, how we can make sure that the critical OI does not go, but then I just put exit code 0. Yeah, we're going to look at all those things in our next lectures, and now we can output it, that you can see it on the console, and now we can also store the files in the GitHub security space. Then we are going to look how we can generate XBond and attach XBond to our image, and of course cosine and sine our image. This we are going to be looking at in the next week, so don't miss it. And if you have gained 1 or 2 things from this lecture, please like, follow, and subscribe. Thank you.